Welcome to The Explainer. I'm your host, and today we're basically assembling a team of cognitive specialists to pull off the perfect answer heist. Think of this as your high-stakes, top-secret strategic briefing for the Cambridge Mathematics examinations. Whether you're currently trying to crack the codes of 0580, 0606, 4024, 4037, or 4040, the vault we are breaking into today contains some of the absolute most elusive marks on the entire paper. We are targeting a very specific, highly secure question format, which is explain in words why a given function is a function. Okay, let's dive right into this. Picture a real Cambridge past paper scenario sitting on your desk. The clock is ticking down, the pressure is on. Now, on one side of the exam hall, we have a student. Let's call him Alex. Alex sees a question asking to explain a function, immediately panics, and just overloads the page with raw mathematical facts. He dumps literally every equation he knows onto the paper, but provides zero actual analysis. On the other side of the room, we have Sam. Sam rushes. Sam sees the word explain, writes down a quick, incredibly vague sentence like it passes the vertical line test, entirely missing the command word requirements for specific algebraic context. And guess what happens? When the examiner's red pen comes out, both Alex and Sam lose the marks. But today we're going to learn exactly how to bypass those mistakes, beat the system, and secure the bag. First, we have to establish the target. The pure value of what we are going after here is staggering. Did you know that explaining why a given function is a function, which means properly assessing its domain, its range, and its mapping, accounts for roughly 15% of the total available marks in certain additional mathematics 0606 paper structures? Think about that. That 15% slice? It is literally the difference between a good grade and an outstanding one. It is the vault that separates the average candidate from the top-tier mastermind. Most students just leave these descriptive questions blank or, like Sam, they rush through them because they're intimidated by having to use words in a math exam. But not us. We are going to treat this 15% slice not as a roadblock, but as our primary target. So, here is the tactical blueprint we're going to follow today. We just covered the 15% target. Next, we'll build a theoretical architecture, followed by our execution methodology. After that, we're going to navigate the examiner traps, unlock the method mark strategy, and finally complete the heist with the final evaluation. Section 1. Theoretical architecture, laying the groundwork for maximum marks. Okay, we're moving into phase 1 of the operation, which is mastering the core principles. You absolutely cannot bypass a security system without understanding how it's wired, right? So the absolutely crucial point here is this. Analytical depth completely overpowers superficial breadth. Examiners are not looking for a data dump. Remember Alex, who just overloaded his paper with unrelated math facts hoping something would stick? Yeah, that is superficial breadth. It doesn't work. The academic benchmarks require logical, structured, step-by-step reasoning. When you see command words like explain, you must deploy a systematic framework. Top students use what we call the PEAL framework: point, evidence, explanation, link. It's a game changer. For example, your point is that the relationship is a many-to-one mapping. Your evidence is physically plugging in two specific x values from the given domain that yield the exact same y value. Your explanation details how this actually satisfies the strict definition of a function. And finally, your link ties it all back to the specific equation given in the question. That is how you build a connected understanding. And before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along, this PEAL framework brilliantly illustrates what the principal examiner reports continually emphasize year after year. Candidates who make cross-topic connections achieve significantly higher marks. It's not just about memorizing what a function is, it's about showing a truly connected conceptual understanding. Let me give you an example. If a question gives you a restricted quadratic equation, say y equals x squared, where x is strictly greater than 0, you can't just define a function in a vacuum. You need to pull in your knowledge of parabolas, domains, and inequalities. You have to actively explain that while a full standard parabola is a many-to-one function, this specific restricted domain trims the curve, making it a one-to-one function. That transferable skill right there, applying core mathematical principles to unfamiliar combined contexts, is exactly what the examiner is desperately looking to reward. Section 2. Execution methodology, the step-by-step blueprint. All right, this is where it gets real. This is where we take the raw data and systematically apply our cognitive skills to physically crack the question. What you're looking at is our exact 5-step procedural framework. Think of it as your lock-picking sequence. Step 1, deconstruct the question. What is the actual command word? Are they asking you to state, describe, or explain? Those mean very different things. Step 2, extract relevant data. Pull the specific domain, the range, and the algebraic rules straight from the text. Step 3, select your analytical framework. Ask yourself, are you proving a one-to-one mapping or a many-to-one mapping? Step 4, execute with clear notation. Use proper f of x notation, properly define your sets. And step 5, present with correct terminology. Let's do a live mental transformation right now to see this in action. Remember Sam's rushed, panicked answer? It passes the vertical line test? Let's run Sam's answer through our new blueprint. Deconstruct. The question specifically asked to explain in words. Extract. Sam completely failed to use the given equation. So if we rewrite Sam's answer using this 5-step methodology, it magically goes from a red 0 to a green check mark. It would sound like this. For every element in the given domain of x greater than 0, the function f of x yields exactly one unique image in the range. Therefore, it is a well-defined function. Boom, that is a mastermind answer. Take this 5-step blueprint and deploy it on the very next practice question you face. Now, a huge part of that execution requires adhering to really strict conventions. Presentation essentially acts as the quality control for your exam answers. If you perfectly explain a function but you use improper notation, like, say, mixing up the notation for an inverse function with the reciprocal, you're gonna trip an alarm. The terminology must be correct, and it must be specific. Words like domain, range, mapping, element, and image are your highly specialized tools here. Use them correctly, and you bypass the examiner's scrutiny entirely. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 3, Examiner Traps, Navigating the Security Lasers. We are now entering the most dangerous phase of the operation, the examiner traps. We've actually extracted the top 3 mistakes directly from the Cambridge Principal Examiner reports. Number 1, vague answers lacking specific details. Number 2, ignoring formatting and presentation checks. And number 3, failing to apply answers to the specific context given in the question. Let's do an interactive data scan right now to test your instincts. Imagine a complex data table in front of you showing a set of x and y coordinates. Let's say x is time and seconds and y is temperature. You have 60 seconds on the clock. If you just write, this is a function because x goes to y, well, you have just triggered trap number 1 and trap number 3. You haven't used any specific details, and you haven't applied the real-world context of time and temperature. Instead, you must say, for every specific second of time recorded, there is one and only one corresponding temperature recorded, demonstrating a one-to-one mapping. Do you see the difference there? It's huge. I want you to look at the stark visual contrast here between what examiners absolutely hate versus what they actively reward. Vague answers are basically general statements that completely ignore the unique context of the problem. They read like memorized dictionary definitions. Specific details, on the other hand, are entirely context-driven. They pull the actual numbers, the actual variables, and the actual real-world scenario from the question prompt and wrap them in proper mathematical terminology. Here's a great rule of thumb. Your explanation of why a function is a function should only make sense for that specific question. If your written answer could be copy-pasted onto an entirely different math problem on a different page and still somewhat make sense, it is way too vague. You need to anchor it to the data you're given. Treat this quote like inside intelligence, leaked straight from the exam board itself. Answers on explain in words why a given function is a function are often too vague. Examiners want specific details. So let's put you to the test with a speed writing challenge. You've got 30 seconds. The function given is f of x equals 3x minus 2. Your command word is explain. Go. Okay, how did you do? Did you use the Peel framework we talked about? Did you state that substituting any real number into the specific linear equation 3x minus 2 results in exactly one unique numerical output? Did you explicitly classify it as a one-to-one mapping? Because if you did, you just flawlessly bypassed the laser grid. Specific details are always the key to unlocking these marks. Section 4, the method mark strategy, the ultimate failsafe. Now, what happens if you stumble during the heist? What if the algebra is incredibly complex, the pressure gets to you, and you lose your footing right in the middle of your explanation? Examiner alert. Show your working. I literally cannot stress this urgently enough. Leaving out your working is a critical error, especially in descriptive questions. Now, you might be wondering, how on earth do I show working when the question specifically asks for words? It's a great question. You show your working by mathematically establishing the domain and mapping before you translate it into a paragraph. If you try to do all that complex logical reasoning in your head and just write down a final flawed conclusion, you get a 0. But if you quickly sketch the graph, explicitly define the domain restrictions mathematically on the page, show a quick algebraic substitution to test the mapping, and then write your flawed conclusion, the examiner can still see your process. Method marks are rewarded for the process, not just the final destination. This fail-safe strategy can literally save your overall grade. To absolutely guarantee you pick up those method marks, I want you to follow this deconstruct, solve, evaluate methodology. 1. Identify the given information physically on the paper. Actually write down domain equals X. 2. Break the explanation into logical steps. 3. Solve systematically. 4. Check for reasonableness. Does your written explanation actually match the math you just did? 5. Make justified recommendations or conclusions. By physically writing down steps 1 through 3 on the exam paper, you are intentionally laying down a breadcrumb trail for the examiner to award you points, even if step 5 goes slightly off course. It is the ultimate insurance policy for your heist. Never leave the vault empty-handed.
Section 5. The final evaluation. Thinking like a top-scoring candidate.
We're finally approaching the vault door. This is where we move past simply answering the baseline question and start thinking at the very highest level of assessment objectives: critical analysis. The absolute crucial point here is that top-scoring candidates don't just describe what they see, they evaluate it. They navigate the descriptive, analytical, and evaluative levels effortlessly. When explaining a function, they naturally identify limitations. For instance, explicitly noting that an inverse function is only valid if the original function's domain is strictly restricted to make it one-to-one. They don't just state things, they justify every single decision with concrete algebraic evidence. This brings us to our final, complete system. It relies on 3 golden rules that essentially guarantee top marks. Rule 1, command word decoding. Know exactly what explain demands versus describe. Rule 2, the Peel framework application. Structure your logic flawlessly every single time. Rule 3, time management matrix. Don't rush and miss details like Sam, and don't overwrite unrelated facts like Alex. Deliver precise, contextualized, method-backed analysis. You now have the complete blueprint to secure that highly valuable 15%. The vault is open. The only question left is, will you actually apply the systematic method we've discussed today, or will you let the examiner traps catch you off guard? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.